How is trigonometry used in aviation? Trigonometry and trigonometric functions are used to estimate distances and landing patterns and navigate around obstacles. According to reference.com, many pilots are also trained in the use of on-the-spot trigonometry to come up with quick estimates of their location and positioning in the airspace. Usually, these calculations are based on the angle and position of the sun relative to a pilot's plane.
Our chosen article is entitled Pilots, Airplanes, and the Tangent of 3 Degrees by Charles R. Moren, Associate Professor of Aeronautical Science, Embry-Riddld Aeronautical University.
The article's objective is to show a practical application of trigonometry in the aviation environment. The equipment required is a scientific calculator with tan function.
The background of the article explains that pilots must sometimes execute visual approaches that are varied in size, shape, and angle based upon a variety of factors such as other aircraft, obstructions, noise abatement, or prevailing weather conditions.
The standard approach angle, however, is 3 degrees. This 3 degrees angle is the standard approach angle integrated into Instrument Landing Systems or ILS and Visual Approach Slope Indicators or VASI installed at many airports. When flying a normal traffic pattern, the aircraft is maneuvered so that the final approach is intercepted at an altitude of 500 feet above the elevation of the airport.
Student pilots must visualize both their flight path over the ground as well as their vertical approach path. In order for students to accurately visualize their ground path, they must first compute the distance they must be from the end of the runway when they turn onto their final approach segment.
Question number 1. In order to fly the standard 3 degrees approach, how long should the final approach segment if the pilot plans to turn at final 500 feet above the elevation of the airport?
If we begin our final approach 500 feet AFE, we can compute the length of our final approach by dividing our altitude by the tangent of 3 degrees. So, 500 feet divided by tangent 3 degrees is equals to 9,541 feet.
Question number 2. If the pilot planned the approach to begin 5 nm, which is a typical distance for an ILS, from the end of the runway, at what altitude should the aircraft be when intercepting the final approach?
One nm is equals to 6,073.1 feet. 5 nm is equals to 3,073.1 times 5. Which is equals to 30,380.5 feet. 30,380.5 times 3 tan is equals to 1,592 feet AFE. Therefore, the pilot should maneuver the aircraft so as to turn final approach 5 nm from the runway at an altitude of 1,592 feet AFE.
Pilots use rules of thumb and printed tables to estimate other important performance variables related to the operation of their aircraft.